So this session is a discussion panel on some of the latest work we've been doing on ODP on IPsec offload. And so we basically have two perspectives on this. From the application side, we have Petri and Bogdan, who have been taking the what is an application want to see view in IPsec offload. And then from the implementation standpoint, we have Bala and Nikhil, who are offering their perspective on what IPsec offload looks like from an implementer perspective. And I'm here just to look good. So I'm just going to fill in. You're right, I know. So basically two aspects of IPsec offload that we are offering in the next major release of ODP, which is codenamed Tiger Moth, following our random butterfly series. The first one is what we call look-aside processing, and the idea behind look-aside is all packets first come to an application thread, and then the application says, oh, this is an IPsec packet, let me decrypt it, or this is a packet that I want to have IPsec encrypted, and it will basically send it down to an IPsec offload engine, which of course interoperates with the crypto block, and then returns the result back to the thread. And we have both synchronous and asynchronous versions of these APIs defined. So you can do a synchronous call to IPsec encrypt or encrypt, or you can do an asynchronous one, and then get a result back as an event completion. For offload processing, it's and this is what currently being defined. We've been working on this week trying to get the API definitions for that, but the idea here is to provide more autonomous capability where similar to the way the classifier works, where the application simply sets up classification rules and then that happens automatically as packets are being received. We want to similarly be able to program IPsec input rules, security association rules, and have them automatically be acted on packet receive and transmit. So an IPsec packet would be received, it would be recognized as such by ODP, decrypted before it ever shows up and the application sees it. Similarly, on transmit, a plain text packet would be sent off for encryption followed by transmission without ever having to come back to the application. So from the application perspective, we have Bogdan and Petri who might want to offer some insights.
Thank you. So we have in ODP this look-aside API, but on top we need to construct an application, a compliant application. We need to have some things inside the application. Of course, we have to have policy database for inbound non-IPsec traffic, for outbound, both for secure and policies for bypass and discard. You need to have security association databases, even if the API will provide an inbound lookup based on SPI. We need to have database, security association database. We need to provide on outbound direction the security association. If we want to store some statistics, we have to have security association database to store some informations. Of course, we need to have outbound cache because we need to search fast on outbound direction and provide security association. For inbound, as I said, the look-aside API provides lookup based on a unique SPI, but if you have multicast traffic, you may also need to have some kind of cache to find fast security association, so an inbound cache. And of course, you need to have interaction with Strong Swan or some IKE v2 implementation. This is that box. And of course, you may know that on Friday we'll have a demo with this setup. One application will be OpenFastPath with a special proof of concept page implementing all those things. Of course, except for integration with StrongSwan, we'll use static security associations for this proof of concept. And asynchronous processing. And during this meeting, Nikhil will present some results as well. Okay, the next. So if you are wondering how the processing is taking place in asynchronous processing mode, inbound and outbound, mainly it looks like this. On inbound, I'm receiving packets in the processing loop on a worker. It's a thread. We are using scheduling. So it's our scheduling packets. And if the packet is ours, meaning the IP is for this node, is ASP or H, then we are processing as IPsec. If it's unicast, we can simply send it to UDP through asynchronous API, because ODP will provide lookup and will identify security association. If it is multicast, then we will search in the inbound cache. This will not be part of the demo. And of course, we receive the termination or the result of the asynchronous processing also in the ODP thread, in ODP worker, as an completion event or asynchronous event. We'll need to process the result if it is the processing was correct or not. Maybe the security association was not found, and then we have to take some actions. Optionally, we have to verify if the inner packet corresponds with the selectors associated with the security association. This is an optional step. And then we will move to processing further the inner packet, because it's a tunnel. But it should work as well with transport mode, going with layer 3 or other headers. On outbound processing is a little bit different, because you are sending the packet from at the end of some processing. In this case, it will be routing. And of course, if it is an interface on which we want to perform IPsec, we'll need to consult cache outbound. And if the cache is found and is protected, we'll go to ODP, providing security association. And on the termination of, on the result of the IPsec processing, in a similar way, we have an event, a scheduled event, process result, and send packet to the interface. So this will be a demo on Friday, asynchronous processing. And as I said, Nikhil will show some results. Thank you.
Yeah, maybe I'll kind of add something without any slides. So the kind of benefit from application point of view, so we have already a crypto API that you can do IPsec, but now adding an IPsec API allows first in a look-aside mode, offload some packet transformation, kind of encryption, decryption, adding headers, removing headers, and then doing some kind of light offload like the essay lookups and inbound and packet fragmentation, potentially packet fragmentation on outbound side. So that's already all in kind of a look-aside mode API. And then, as Bill mentioned, we are working on inline version of the API. So it's actually adding just a couple of configuration options there to enable or kind of offload one extra round trip through the application, so that packets when they come into the system, if they are IPsec packets, they are already inbound processed before application sees it. So it's kind of offloading extra cycles through the application code and the schedulers and queues and such. So it should give another bump on the performance. So compared to crypto usage of crypto API to the inline, it should be major performance increase.
Hello, good morning everyone. So basically we'll go through what currently look-aside APIs offers. So in addition to the crypto processing, IPsec API offers the complete IPsec stack to be offloaded to the hardware. So like we can push the IPsec headers in the hardware. There are different bottlenecks in the IPsec processing. Basically, one is sequence number update, which is like every packet will have to go through an atomic operation in case of updating in software or atomic queue. So if you offload it to the hardware, hardware will take care of that. Then for the IPsec header, we need to generate a random IV number for every packet. So that will be taken care in the hardware. Anti-replay checks, ICV checksums, and obviously the crypto operations. So as Bill mentioned, in this approach, all the packets coming will be hitting the GPP first, and then if IPsec processing is required, there'll be interface through which we can like. So this is basically depicts the application and implementation domain segregating. Below is the implementation, what implementation is taking care of basically in the hardware, and what application needs to do in the software. So packet is coming via scheduler or directly through some queue APIs. So basic on the, so when you receive a packet, you check whether you have got an encrypted packet. If you have got an encrypted packet, you send it back to hardware, and hardware does the IPsec related processing. Send it back via ODP schedule again. You do the route lookup, policy lookup, and then if again the IPsec processing is required on that packet, it goes via again the same crypto API. So the hardware interaction during this is a bit more. So for that we have inline proposals. So by offloading this to the hardware IPsec protocol processing, so we have some significant performance improvements. So this blue blocks here shows the kernel IPsec stack performance, and this gray bar is the ODP example application that we have written over these APIs. So you can clearly see the difference. So it is approximately like 11 times can perform what Linux stack can perform. Obviously, there are some additional stuff in Linux, but we have also ported this OFP application over ODP, so that also outperformed kernel with a significant gain. So next is like we have this ODP inline offload proposal that is work in progress. So basically in this model we have increased the implementation domain and reduced the application so that more offerings and more things are offloaded to the hardware. Like when a packet is received, it is already checked in the hardware whether it is ESP or AH, and it directly goes to the hardware crypto engine instead of going to the application and coming back to hardware again. So in this approach, so if it is an encrypted packet, it will be looked up in the hardware, it goes to crypto module, and then after being decrypted and removing the IPsec headers, it goes back to application then. So then application checks whether it was a packet received plain or it was like decrypted by the hardware. So you can check the IPsec results, and you just need to do the routing in the software, and then on the hardware side, it will again do the policy lookup in case it needs to be encrypted. If it needs to be encrypted, it will go to the hardware crypto block again, and then out, or otherwise it can go directly out. So there we can have a traffic manager as well, on the receive side, we can have classifier as well. So this reduces the hardware interactions the application needs to do for the crypto operations. So basically in this proposal, we IPsec of Bala, you want to go through it? So packets are received directly by the IPsec offload engine instead of going to the GPP and then coming back. Then this is like lookup is being offloaded to the hardware. So you can run the classification rule post IPsec on the receive side. Packets are like, after encryption, packets can be directly transmitted to packet.io or via the traffic manager APIs. So we have done some POC based on the draft APIs, and this is what the performance difference. So these 3 bars were earlier there. So this is the green bar with the inline offload that we have achieved. So it is almost hitting 20 Gbps with IMX traffic on single core itself. So rest of the cores are free for application to process any control plane or other processings. So there is a significant boost in the performance here. And we'll be having demo for these 3 applications on Friday. So see you guys there.
Great. I mean, I think these are really impressive results because you look compared to the Linux kernel is hardly visible at this scale compared to the being able to get effectively line rate with a single core by just offloading the full IPsec path. So, any questions for anyone here? Yes.
I'm trying to understand how the OFP IPsec application is different from the ODP IPsec. OFP is also, if I understand, is built on top of ODP. So what exactly distinguishes it?
So OFP is doing much more, actually doing routing and actually storing the databases, policies, and part of the security association databases. And also the caches for, at least for outbound direction, you have to have to provide to ODP the security association. So you have to do a lookup in application level, meaning in OFP in this case. And also OFP provides configuration means by API or CLI. You can configure it. Actually, for the demo, we'll have a configuration file that the syntax is similar to IPsec tools from Linux, so it's not exactly, but it's similar as concept.
So I need an IPsec implementation on ODP.
Yes.
Why would I choose one over the other? Besides performance, obviously you're saying.
If you need a stack to do what a network stack should do, then.
So there's no network stack in the ODP IPsec implementation?
So ODP is not doing networking stack.
It's an example. The ODP IPsec application is an example application. So
Okay, so for practical purposes, you would still use the OFP.
So ODP IPsec is kind of example application doing kind of. I think it's kind of doing a gateway type of thing that it's kind of terminating the other side, the IPsec, and then maybe Nikhil can comment a bit more. But OFP obviously is a full IP stack that it's kind of has TCP and every kind of routing protocols, whatever. So it's a full stack.
So are you working with the OFP guys?
Yeah. Of course. Yeah. Of course. Yeah. So. Yeah. So it's kind of working on parallel at the same time. Yeah.
So just one more point. OFP is still not based on these inline APIs, that green bar that is shown. It is still based on local-side model. So moving to the inline model, that will be a significant boost in performance for OFP as well.
So from the ODP perspective, what's the difference between the inline and the local side?
from hardware perspective, it is like, one is like you're reducing the hardware interaction with GPP because hardware is from interface, network interface packet is directly coming to the crypto block, not going to the GPP and coming back and then
Right,
going
so it's the inline.
within line, yes.
So the hardware has to support inline, right?
Yes.
Okay, so it's now like you have to have a hardware feature to support inline.
So it's a capability. So
Right.
yeah, so
It's reflected in ODP.
your
Yes.
ODP API, ODP IPsec API has a capability flag if inline mode is supported or not. So the Luca side should be always supported, but inline is kind of, if that's supported, then application can choose that. Yeah.
So, one of the goals for ODP is portability across different platforms. And so when this feature is introduced in official release, all ODP conforming releases will support inline. Now, whether the inline leverages full hardware capabilities or whether the ODP implementation is doing all or part of that in software will vary based on platform. So, for instance, in the Linux generic reference implementation, everything will be done in software, and obviously you will not get the performance boost, but you will still have the application doesn't have to worry about it. Okay. This is NXP's platform. Yeah.
How many IPsec flows or how many secretary stations you have in this measure?
This is 128 essays and 128 flows.
On the inline, how do you deal with replay check?
Sorry?
Replay check.
So it will do the anti-replay check. So here, when you receive a packet on the inbound side, it does the essay lookup. We found the essay, so hardware will tell you if there is any error in the packet, is there any anti-replay failures, or is there any ICV failures. So it will report back in the results structure, and that IPsec event will show you that you'll check in the IPsec result, is there any error bit is set for the packet.
Okay, so the expectation is that the inline offload includes replay check.
Yes.
Error reporting will
Error.
come out as a
Looker side mode, it's assumed that SL lookup is done in hardware, right?
Yes. Yes.
Not listed as one of the performance
Essay lookup on the inbound side will be done in the hardware. On the outbound side, it will be done in the software.
So on the outbound side, you don't give a SPI to the
Because policy are not offloaded in the looker side model.
policy, but then you still have the SPI, so based on SPI, you have to do
On the outbound side, you don't have SPI, you'll have to do the policy lookup.
after the policy.
Yeah, that is done in hardware. The essay lookup.
Yeah, even the outbound.
So just comment on so this is under, this inline stuff is under work. So we are kind of debating if the policy should be under the API or on the application side. And we may take it in phases, so that's my proposal, to take it in phases so that the policy lookup is not in the ODP in the first inline phase, but maybe added later like it's in the picture. So. Yeah, Luca side, it's in the inbound. There is a kind of option to have the essay lookup in ODP side. So not on the kind of in Luca side. There's no outbound essay lookups, only inbound. And actually, their application can choose to just shuffle the packets there and make the offload in the essay lookup offload on ODP side. Or if you already know the essay, you can also give packet and essay through the API. So there's an option to use the offload or not use the offload. Outbound side application always gives packet and essay.
Right.
Yeah. No.
SA is configured in the hardware.
Yeah.
That lookup is still done in the hardware.
The
actual keys to the hardware.
So outbound, application first creates the essay, gives all the keys and all the parameters, lots of parameters, And then on outbound, it always gives packet and essay, packet and essay.
So when you say essay, that's the SPI.
Yeah, and all the configuration, yeah, including SPA, yeah. Inbound you can choose if you want the implementation to do the SPI lookup for you or not. So inbound, it can do it. Outbound application always gives the explicit this essay, this packet, this essay, this packet.